everyone, and welcome back to the new video of this channel. So today I will be solving a problem which is append character to string to make subsequences. Leetcode 2486 problem. So let's see the problem students. So before moving forward in this video, please make sure that you have liked and subscribed to this channel. And also it's my advice to all of you that please read the problem and try to build up the intuition. Then try to do the code. Then it will be beneficial for you. So let's read the problem statement. So problem is saying that we have given two string s and t consisting of only lowercase English letters. So we have to return the minimum number of characters that need to be appended to the end of the string s so that t becomes the subsequence of s. So it is this line is saying like we have to make the string s such that t should be the subsequence of string s. So I'll tell you about this. So a subsequence is a string that can be derived from another string by deleting some or more no characters without changing the order of the remaining character. So subsequence is defined as something like we don't have to change the order of the characters. Like it is same as the we can say subarrays. Subsequence is same as the subarrays, but the order of the character shouldn't change. So let's see the example. So example is this one. You can see. Sorry. Yeah. This is the example. Coaching and coding. So we have to make the this string as such that t should be the subsequence of string s. So you can see here C and C are same, O and O are same. Now let's see D is present in this string or not. So you can see here D is not present, so we have to add D here. We have to add D in S string. So after adding D, it will be something like COACHING, and after adding D, you can see D is the different character. So we have to add this full string. So DING, I have added. Now you can see here T is the subsequence of this string. You can see here CODING. This is the subsequence because we are not changing the order of the characters. So let's see the example 2. So example 2 is same like this. ABCDE is the string S and A is the string T. So you can see A is present in this string already, so we don't have to change the characters or we don't have to add the characters in this string. Append means adding sub characters, adding something. It can be it can be based on the numbers, it can be based on the characters. So you can see we don't have to change the string s because A is already present in this string, so we don't have to change this, and that's why the answer will be 0 because we are not changing the string s. Here the answer equals to 4 because we have changed the string s like this. 4 COCHING is the same string, and we have added DING in this string s. DING in this string s. So DING 4 characters we are added, so that's why answer is 4. Here we are not added any characters, so that's why answer is 0. You can see this string also s equals to z and t equals to a b c d e. So you can see here for making the string s such that t can be a subsequence of this string s. So you can see here a b c d e. No character is present in this string s. So that's why we have to add all this string like a b c d e. After adding the string, it will be z a b c d e. As string s will be z a b c d e, which is the subsequence of string t. No, sorry, string t is the subsequence of string s now. So we are added five characters because a b c d e length of the string t. We are added 5 characters, so that's why answer is 5. So that is the simple explanation of all examples. Now you can see the approach. I told you about this key. What is subsequences? Like these are the subsequences, but ACB is not subsequences because here we are changing the order of the character. That is not a valid condition for the subsequence. It is a subarray. I know it is a subarray, but it is not a subsequence because we are changing the order of the characters. So I told you about the all the examples. So Now let's directly see the approach for this. So for approach part, I am taking the first example, which is string s equals to coaching and t equals to coding. We have to make the string s such that t can be a subsequence of string string s, sorry. So you can see here c and c are same, o and o are same, because by here we are using two pointer approach. That is the optimal approach, because we have to keep traversal of string s and string t, and we have to check the the characters are same or not, the characters are different or not. We have to check this also. So that's why we are taking two pointers I and j, and now we are checking like if s of I equals to s of j. In this condition we know that the characters of the string s and string t are same, so we have to increase the pointers. So look, we have to we have to make the string as such that it can be subsequence of string t. So here we will check like if the first character of string t is same or not. C is same, yeah, c is present in this string, so that is the barrier condition. Now I'll increase the pointer of j, and now again I will check like o is present in this string. You can see here o is present. Then again I will increase the pointer, and now I'll check like d is present in this string or not. Now you can see d is not present, so that's why what we will do, we'll add all this string, remaining string of string t, ding, we will add this string, and after adding it will be something like this, coaching and ding. So we are adding four characters here, so that's why answer will be 4. So what we are doing is, now my pointer is here at index 2. So the length of the string t is 6. You can see here 1 2 3 4 5 6, the length of the string minus the pointer j. So after deleting the, after subtracting the this length of the string t and minus j, that will be my answer, because the length of the string is 6 and my pointer is at index 2. So 6 minus 2 equals to 4, and 4 is my answer, because what we are doing is we are just adding this string, remaining string ding. So the length of the string is total length of the string minus length of the this string up to j. So that will be my answer. So let's directly do the code for this. So for coding part is very simple. What we will do, we will firstly define the size of the string. So int n equals to s dot size of the string s, and int m equals to t dot size. Now I will take two pointers. Initially, both pointers will be at index 0. So in I equals to 0 and j equals to 0. Now I will apply a loop like while I is less than n and then j is less than n. This is the basic condition for two pointers approach. Now I will check like if s of I equals to t of j. If my characters are same, that is the good condition. If my characters are same, no need to change anything. I'll simply increase the jth pointer. Jth pointer in starting. Jth pointer is showing the string t, and ith pointer is showing the string s. So you can see if my characters are same, I'll simply increase the jth pointer, and in all cases I have to increase ith pointers also. So after this, what I have to return? I have to return the length of the string t, the length of the whole string. So the length of the whole string is basically m minus this string up to j string मेरे को return वो subtract करनी पड़ेगी. So m minus j I have to return, and if I run this code, yeah, it is working perfect. You can see here. Now I have to submit this code and see if this will work or not. You can see here it is working perfect. So now let's discuss about time and space complexity for this solution. So the time complexity for this solution will be big of n, because sorry, it should be big m. It will work in n also. Yeah, you can see here it will work in n also. But why we are using like j is less than m, because we know that always n should be greater than m for subsequence, for making the subsequence, because t को subsequence बनाने के लिए like we have to make the string as such that t should be the subsequence of s. So definitely s will be greater, the size of the s will be greater. So that's why it was working like I less than n and j less than n, because it was working. But j less than m, will be the optimal, because we are just using the simple traversal. We are contacting the traversal also here. So we are not doing the traversal up to n, we are doing the traversal up to m, but that is less than m, less than n. So that is a better approach, optimal approach. So you can see here, we know that n is greater than m. Definitely the size of the string s will be greater than size of the string t. We know this. So the time complexity will be big of n, because we know that n is greater than m. If m is greater than n, then in that case the time complexity will be big of m. Whichever is greater, the time complexity based on that. So here the time complexity is big of n, because we are just using the simple traversal, and the space complexity is big of 1, because we are just using the two pointers and we are not using any extra space. So the time space complexity will be big of 1. So this was the code, and if you find this helpful, then please like, share, subscribe. Bye.